Let's start reviewing through. So number 1 says list the first 6 perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. Because I'm going up. List the first 5 perfect cubes. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. List the first perfect fourth powers. 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. 4 times 4 times 4 times 4 is 216, I think. Yeah. That's about all you have to do there. All right, so for 2 through 16, and I guess it could go to the back, but we'll just cover 2 through 16. It says rewrite each as a radical when necessary. So number 2 is already a radical. Number 3 can be written as a radical. This is how I write it. Okay? Remember we went over that property. Number 4 needs to be written as a radical. So it's negative 27 to the 1/2 power. So that's the square root of negative 27. Number 5 is already a radical. Number 6 is already a radical. Number 7 is already a radical. Number 8 is already a radical. Number 9 is already a radical. Number 10 needs to be written as a radical. So 49 to the 1/2 power is the square root of 49. Number 11 needs to be written as a radical. That's going to be the third root of 8. Okay? Number 12 needs to be written as a radical. So it's the third root of 64 raised to the 2nd power. Number 13 needs to be written as a radical. That's going to be the square root of negative 4. Number 14 is already a radical. 15 needs to be written as a radical. 7 to the 1/2 power is the square root of 7. Square root of 7. And you could put it to the first if you wanted to. Number 16 needs to be written as a radical. 36 to the 1/2 power. It's going to be the square root of 36. Okay? So that takes care of part A. So if it was written as a radical, rewrite it as a radical. Okay? All right, so part B, I'm going to come back to part B. Let's do part C next. Okay? All right, so the answer to number 2, what's the square root of 16? It's just 4. Agree? Number 3, what is the third root of negative 8? What times what would give me negative 8? Negative 2. So negative 2 times negative 2 times negative 2 gives me the negative 8. So if I found just the third root of negative 8, that's equal to negative 2. Okay? Then I'm going to square it. What is negative 2 squared? 4. Okay? Problem number 4. Is there a square root of 27? Is 27 a perfect square? No, and it's negative, so that's going to mean something later. Number 5. What is the third root of negative 8? Well, we just did it up here. What's the third root of negative 8? Wait, which number am I on? 5, thank you. So this answer is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. Is there a third root of 16? So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Is there a perfect cube for 16? No. Okay. Number 7. Number 7. What is the third root of 27? What times what times what gives me 27? 3. Number 8. It's the square root of 1/4. What's the square root of 1? 1. What's the square root of 4? 2. Number 9. Is there a number I can multiply by itself 4 times to get to 12? No. Is there a number I can multiply 4 times to get to negative? No. I can't go negative, 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 negative and get a negative answer. Okay, number 10. They just want the square root of 49. That's equal to 7. Number 11. What's the third root of 8? What times what times what gives me 8? 2. Number 12. I could do it one of 2 ways, and they're both correct. One's going to be a little easier than the other. I can do the first thing. I can go 64 and square 64 and get 4,096, and then take the third root of 4,096. Or I can find the third root of 64. Do we know the third root of 64? It is a perfect cube. So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. What is the third root of 64? 4. So I get 4, and then I have to square it. What's 4 squared? 16. Okay? Can I do the square root of a negative number? No. Okay, I can do the third root. Number 14. Can I find the square root of 7? If I have a calculator, yeah. If I don't, no. 15, can I find the square root of 7? Same thing. And then what's the square root of 36? 8 times 8 is 64. 6 times 6 is 36. Okay, so now I want to go back and I want to classify as an integer, a rational number, an irrational number, or a non-real number. So first thing I'm going to do is let's classify if it's an integer or not. An integer is a negative number, a positive number, and 0. That is a number, not a fraction or a decimal. Okay? So let's classify as integer. We'll go backwards. Number 16, integer or not? Yep. So it's an integer. Nope, nope. So I didn't have answers. Is 16 an integer? Woo! Okay. All right. Is number 11 an integer? Is number 10 an integer? And I'm just looking for answers that are numbers, not fractions or decimals. Is number 8 an integer? No, it's a fraction. Number 7 an integer. And the ones that we don't have anything written on yet, or anything down at all, it just means, is number 5 an integer? Integers are negative and positive, so is it an integer? Yep. Are both of those integers? 4 is an integer, 4 is an integer. Cool. We've just identified the integers. We don't have to do anything more to those problems. Okay, next. We want to list it as a rational number. A rational number, remember, is a fraction or could be written as a fraction, meaning like it was 0.25. 0.25 is the same thing as 1 over 4. So we want to know if it's rational or not. Okay? So those are not done. It's not done. It's not going to fall. Is that rational? Okay. Any other fractions? Nope. Okay. Irrational. The irrational number set is huge. So irrational numbers are decimals that do not repeat. Okay? Irrational numbers are square roots or cube roots that aren't perfect squares or aren't perfect cubes. Okay, so a perfect square would be like 1 and 4 and 9 and 16. Those are perfect squares. But if I had the square root of 2, the square root of 3, the square root of 5, the the square root of 6, the square root of 7, the square root of 8, the square root of 10, the square root of 11, square root of 12, square root of 13, square root of 14, square root of 15. Keeps going forever. Those are all irrational numbers. If I were to take the square root on a calculator, it's a decimal all the way out. It will continue. The calculator will just truncate it off. Okay? So, let's find what are irrational numbers. Can I have the square root of a negative? Nope, so this is not going to fall into that category. Ooh, number 6. What is number 6? Number 6, the third root of 16. Is 16 a perfect cube? It's a perfect square, but is it a perfect cube? Yes. What times what times what gives me 16? 2 times 2 times 2 gives me 8. 3 times 3 times 3 gives me 27. So number 6 is a irrational number. Okay, I'll put IR for irrational. I was integer, right? Number 9, it's the fourth root of a negative, so that's not going to happen because it's a fourth root. This is not going to happen because it's the square root of a negative. Number 14, square root of 7. It's a forever decimal, so that's irrational. Square root of 7 is irrational. It goes on and on forever. Okay? Then the last one, we want to identify if it is not a real solution. It doesn't fall into the real number category. So that would be a square root or a fourth root of a negative. Okay? Third root of negatives exist. So, square root of negative 7, not real. Okay? Number 9 was the fourth root of negative 12. Not real. Square root of negative 4. Not real. And that's how you do that whole front page. You can pick 2 questions from 17 to 27. Yeah.
Could you say the
Number 1. So perfect squares are 1, 4, 9, 16, 25, 36. Keeps going forever. Perfect cubes are 1, 8, 27, 64, 125. That's the first 5. First 4 perfect. Fourth, 1, 16, 81, 216. Cool? We'll probably have them listed for you. I mean, the only way to get to them is to go 1 times 1 times 1, 2 times 2 times 2, 3 times 3. And you get to use a calculator. I'll show you how to put power pretty easily. Any question? 2 questions I'll answer from 17 to 27. Yeah? 23. You got it. All right, now number 23. We have 4 over 9, and this is raised to the 1/2 power. The 1/2 power is the same thing as the square root. So technically, this 1 right here goes right there. But if I raise something to the first power, isn't it itself? Okay, so what is the square root of 4? 2. What's the square root of 9? That is an irrational number because it's a fraction. Yeah. 24. 24. I have 4 raised to the 3 over 2 power. Okay? So, 4 is going to be under the radical. The denominator goes here. The numerator goes here. Okay? What's the square root of 4? 2. What's 2 to the 3rd power? 2 times 2 times 2. 8. That is an integer. Okay?
number 26 be 0?
What's that?
Number 26 be 0?
5 to the 0 power is 1. Any number that's not 0 that's raised to the 0 power comes out to 1. 28 I'll do. Alright, number 28. So they have b squared minus 4ac all over 2a. And they want us to substitute a in, which is 2, b in, which is 3, and c in, which is negative 2. So I'm just, wherever I have letters, I'm going to plug in. Notice I have a negative 4 that's already in there that I'm not going to worry about. You know, it's going to come along to the right, and then a 2 in the denominator. Okay, so my a value, 2, is going to go right here. My b value, 3, is going to go right here. Oh, I forgot one of the a values. There's another a value right there. And then my c value is going to go right there. Okay? So let's plug them in, see how we do. So I have b squared. Well, we said b was 3, so I have 3 squared. Is that okay so far? There's a minus sign, followed by a 4. That 4 is a constant. My a value I said is 2. My c value I said was negative 2. All over my a value I said was 2. Is that okay so far? All right, let's see if we can figure out the math behind it. Okay, underneath the square root sign, what is 3 squared? 9 minus, okay, so let's see, I have a negative times a positive times a negative. Negative times a positive times a negative. Is it positive or negative? It's positive. Right? So 4 times 2 is 8. 8 times 2 is 16. And then 2 times 2 is 4. That okay so far? What's, if I add 9 and 16 together, what do I get? 9 plus 16. 25. This comes over to square root of 25 over 4. What's the square root of 25? 5. That's my answer. 5 over 4. And then number 29. Is it possible to find 2 rational numbers that multiply to an integer? 2 rational numbers that multiply to be an integer. 2 rational numbers. A rational number can be written as a fraction, right? Do you agree? So is it possible that I find 2 rational integers? If I multiply 3 over 4 times 4 over 3, I get 12 over 12, and 12 over 12 is 1. So is it possible? Yes. All right, make sure your names are on those and pass those forward, please. Okay. Exponential functions and sequences, simplifying radicals. So we're going to simplify a radical, okay? So we're going to go slow through it. It'll take us the rest of the period to hit through this, but I want to make sure you have an understanding of it, okay? So can I move to the next slide? Okay. So, square root of 16?
4.
So everyone agrees with 4? Square root of 100? Okay. So let's think about this for a moment, just to take 16. Is 16 the same thing as 4 times 4? So there's a pair of them. It's a square root. The pair works because I want the square root. What about 100? It's the same thing as what times what? 10 times 10. See how there's a pair of them? See how I broke that down? Being that there's a pair and there's that little 2 here, but we're lazy to write it, we're looking for the pair. So the square root of 4 times 4, which is the square root of 16, is 4. The square root of 10 times 10, which is the square root of 100, is 10. Okay? So I know that just getting to the red numbers was quick. but the math behind those is the blue. You're realizing, oh, I have a pair. Okay, does that make sense if I make that statement? Can I move to the next slide? So, yeah. What? Oh. All right. So here's a list of perfect squares. We don't list one as a perfect square because one's a perfect square, it's a perfect cube, perfect fourth, perfect fifth, sixth, perfect millionth power. Okay. So those right there are perfect squares. Okay. How did we get to 4? Well, that's the same thing as 2 times 2. How did I get to 9? That's the same thing as 3 times 3. How did I get to 16? That's the same thing as 4 times 4. Remember what we just did where we had the pairs? 25 is 5 times 5. 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12. There is an infinite amount of perfect squares, absolutely. Okay? So remember what we just did on the last slide. If we go back to the last slide, I just called all those. 2 times 2, 3 times 3, 4 times 4. Look at this. 4 times 4, 16, 10 times 10, 100. Okay, same idea. All right. Square root of 300. Square root of 300. I am just a little bit big, smaller than 250. So, let me do this. Let me ask you all this. Is 100 a perfect square? Do you all agree that 100 is a perfect square? Anyone going, dude, you just lost me. So, if I were to write 3 times 100, would you feel comfortable with what I have up there so far? 3 times 100 is the same thing as 300? Would you agree? And you have a question.
So will we be able to use our computers?
Heck, your calculator? Absolutely. Yeah. But now here's the problem. You'll be able to use your calculator, but if you found me the square root of 300 on your calculator, 17 point big old decimal. So what we want to do is we want to start breaking them down to this fashion. So does everyone feel comfortable that 3 times 100 is equal to 300? Is there any part of that conversation you're like, dude, that happened? So 3 times 100 is indeed 300. Now 100 is our largest perfect square that goes into 300. 3 times, right? Does that make sense? Now 3 is a prime number, meaning I can't break 3 down any further. So if I could say 3 times 100 is this, could I say that 3 times 10 times 10, would that still fall under the same category? And I guess I could break 10s down to 2 times 5. So I could go 3 times 2 times 5 times 2 times 5. But I'm not going to get there. I just wanted to show you how I can start breaking some numbers down. Okay? So this part right here is not the most magnificent, perfect part of this problem, so I'm not going to worry about it. So what I want you to do is I'm going to show you this little property that looks like this. If I have A times B, where A and B represent 2 numbers, I can break that up into square root of A times square root of B. Is that okay? So if I have A times B, which A and B represent any numbers I want, I can break those apart. So with this knowledge right here, how would that apply to this? Using the 3 and the 100, how would I apply that rule? A times B, where A and B are any 2 numbers being multiplied together. Yeah, exactly. I like that. So I'm actually going to list that. So let's call that our A value. We'll call that our B value. Yes, we could have flip-flopped them. All right. Okay, so how will I write this looking like that, but not using A and B. I have square root of 3 times square root of 100. Is that okay?
Yes.
Now, square root of 3 is 1 point something. Okay? But I'm not worried about some decimal that's this long. So I'm going to keep square root of 3 at square root of 3 right now. What is the square root of 100? 10. So now I'm going to change this to square root of 3 times 10. Now, just to clean this up, I want the radical part to be second. So if I have one number times another, can I multiply them in a different order and get the same number? So if I went 5 times 6, that's the same thing as 6 times 5? So watch this. I'm just going to rewrite this to be 10 square root of 3. Now, guys and girls, while you're writing that down, I want you to kind of think about this for a moment. You guys are part of a generation that I'm pretty confident sometime during your life and closer probably to later in my life, hopefully I see this. I'd like to see that. I think it'd be fantastic. What we're planning a really cool adventure. Okay? In the 1960s, John F. Kennedy said, we plan to go to the moon with a man and bring them back again, not because it is hard, or not because it is easy, but because it is hard. Okay? Now, I just wanted to convey to you where you guys, some of you, or some people of your generation will be going. They are looking to try and put a person on Mars, or some people to Mars. Now, I don't think they'll fly those people to Mars and say, see ya. The first thing that's going to take place is they're going to launch something that will go to Mars with people on board that will orbit Mars, and then it'll make its way back. Now, it's like 11 months there and 11 months back. That's a long time. It's almost 2 years you're in outer space. It's kind of cool. You're floating around like, dude. Now, there's... Well, I don't know if you're sitting. I mean, you're probably floating around because you're in space. Now, things that they have to be worried about in outer space. One, it's not Star Wars and Star Trek. We don't have warp drive or hyperspace. We have rocket goes, and then it kind of runs out of fuel, and then you need enough fuel to go to come back. That's my imitation of thrust. Okay? So what's going to happen is they're going to have this capsule that people are going to be in, and they'll be strapped into it until they're in space and the thrusters are off, and then they get to float around and look at each other for a year, and then say, oh, look, there's Mars, and then bye, and look at each other for another 11 months on their way back. Yeah. What's that? Spaceship inside a spaceship. I'm with you. Oh, that's a good forward.
How long does it take to get to the moon?
That's good forward. 3 days. That's good forward thinking. I like what you're thinking. 3 days to get to the moon.
3 days to get to the moon. Like 15 minutes to get in space.
Isn't the moon like the last one on like the orbital planet? You know how like no, I swear. No, I swear. Like the last planet.
The
The
moon?
moon is not a planet.
The moon is a celestial body that orbits the Earth. It goes around the Earth. The Earth goes around the sun.
Oh yeah.
The big yellow one's the sun.
No, because
No, it really is.
Preston will remember this. We were in 3rd grade and Miss Thrall was explaining it, and they had planets and like hanging from the ceiling in like a line,
Okay, Copernicus.
and the moon was the last one.
The moon isn't a planet.
The closest to the Earth.
Okay, so your job eventually is go look on YouTube the distance of the planets from the sun, and they'll give you a whole tutorial, and you'll find out
That's
what.
boring though.
I know, but throwing back at us that the moon is the furthest planet away, it's just downright hilarious.
Okay, well I may be thinking of Pluto.
Okay.
Maybe. I'm
So-
not quite sure.
So my point on this is, we when we were doing the math equations that go into the physics equations to propel this rocket to aim towards an object that is moving, how do you know it's moving? Because it revolves around the sun. Okay? You have to have something called an exact answer. If you take out a decimal, even 10,000 places, if you're going a couple 100 million miles, there's a little bit of error that's going to take place. Now, a little bit of error, me walking from me to you, the error I have to do this to get here. Now, for me to you is from me to the sun, 93 million miles away. I won't know I'm on a collision course until, So we have to make sure we are positive. Now, we're not going to go to the sun. Don't worry. Okay? It's a little too hot. Although it'd be funny, we all speak real funny on the sun because you have hydrogen and helium are the main two gases on the sun. If you inhale helium, you talk real funny. You know if you inhale hydrogen, you even talk at a higher pitch because sound travels faster through hydrogen than it does through helium. Kind of cool. Yeah, Mars is not going to be a real nice climate. It's nothing that people should be going, dude, I'm going to bring my bathing suit to. They're going to have to be in some sort of capsule. But, I mean, those are all thoughts that have to take place. It's like, okay, not only do we need to make sure that we have this thing, so you shoot baskets, right? And I know you're good at it, right? Doesn't matter what Sunshine over here says, but I know you're good at it. I've watched you play. I love watching you play.
It's okay.
Okay, now, so let me ask you this. Why is a 3-point basket worth 3 points and a 2-point basket worth less?
I know.
No, I'm not talking to you.
I know though.
It's farther away, right?
Yeah,
So,
it's
is it harder to hit a 3-point basket than a 2-point basket?
Yeah.
Now, if someone's in your face, I get it. But if you're just, if you're standing right there in the key and you hit a 2, you should be all day long. A 3, not as accurate, right? The reason it's not as accurate is because you probably are still doing the same type of motion to get it there, right? Most of you aren't doing that granny shot. If you are, I'm going to point and laugh. So, the further that basket gets away, the harder it is to hit it. Do you agree? That rocket ship is the same as a basketball. That rocket ship has one thrust forward. It's launching forward once. Does that ball change direction in air unless affected by anybody else? If someone swats it, yes. But if you throw it in there, that basket, does that go boom?
No.
No. Because you don't have another force acting upon it. Same thing with outer space. That basketball is like a rocket ship. The further you get away from something, the harder it is to hit it. But if you have an exact answer, which would be 10 square root 3 is an exact answer, you're going to be able to hit it than if you took even a decimal out this far. Okay?
It's like a basket.
There's a what?
And I put it in front of it.
Huh? Oh, I have no idea. That'd be kind of good. Although if it rains diamonds, man, it'd be cool to see diamonds, but I know that hail hurts when it hits you. I can't imagine a diamond hitting you. All right,
Oh, wait,
So-
I know what
ready? Here we go.
basket.
Here we go. See if you can follow along with what I'm doing. I just did this one. So, I just did this one. Notice the things that I have up there. What did I circle? 100. 100 is a what?
Perfect square.
Perfect square. So I'm looking for the largest perfect square that can be made up of our number. So we just did this problem. That's all I did. Can I move to the next screen? So watch what I'll do. Watch what I'll do. Okay, everyone see it? What did I circle? 16. 16 is a what? Perfect square. 16 is the largest perfect square that goes into 48. 3 is not a perfect square, is it?
No.
Can I move to the next screen?
Oh, so you found the square root of 16 and then added it to 5 more.
Multiply it to 5.
Oh.
Ready?
Oh.
Follow along. Ready?
You should multiply by the number in place.
What did I circle?
The 4.
4 is a what?
Perfect square.
4 is the largest perfect square that goes into 12.
Yes.
Now, some of you are like, yeah, but what about 6 and 2? Does 6 or 2 appear to be listed on the perfect square list? No. So 6 and 2 are not perfect squares.
Where are you getting that 3 from? A square.
4 times 3.
He said, where'd you get the 3 from? Like.
So 12 is the same thing as 4. 4 is the biggest perfect square goes in. 4 goes into 12.
Also, how many times 4 goes into 12?
So you're just breaking it apart. Because 3 times 4 is indeed 12. I can break that then apart. And then I took the square root of 4 and I got 2, so I just rewrote the order. Can I move on? Ooh. Ready?
What would be the easiest way to figure out which number you should pick to get into it? What would be the easiest?
So you will have a list of the perfect squares, so you have to kind of think of those first.
Yeah.
Don't be like, oh, it's an even number, it's divided by 2. Don't look at it that way. Look at it, oh, could 4 go into it? If 4 could go into it, could 16? Because 4 and 16 are
Pretty much go to the highest you can go.
So what number did I circle up there? 36. Because I know that 2 times 36 is the same thing as 72. And 36 is my largest perfect square. That happens. And then I realized that the square root of 36 is 6. So 6 times square root of 2. 6 times square root of 2 is the exact same value as the square root of 72. It's just we have rationalized it. We have broken it down. May I move to a board? Ooh. Let's pause for a moment. Now we have other stuff. So let's do this. 3 times 2 is 6. Everyone still with me?
Yeah.
And then inside is 24. Okay, let's just pause there for a minute. Does everyone feel comfortable with what I've just done? I multiplied outside to outside and inside to inside and kept them multiplied together, but I can't multiply a number times a radical.
Oh, I see. So you multiply the 3 and 2, which is 6, and then you put 24 into what's it called?
Under the radical. All right, now, I'm looking at this part only. Okay, I just wrote every step up there, but let's look at it real quick. We had the 6 root 24. I then go to my perfect square chart. I realize that 4 times 6 is 24. 4 is my largest perfect square that goes into 24. So once I've done that, then I have the square root of 4, which I know is 2. And outside to outside, I'm going to multiply. So I multiply 6 and 2 together to get 12, and the root 6 comes along for the ride. So, my friends, would you start page 13? Okay, there is a 14. I'm going to circle the 14. I just want you to try and get through page 13 tonight. Deal? Get out of here. Have a great day. Take care of one another.
You 14 minutes.
We'll get there.